just in case he's not in time, and if anybody else has missed it, we can maybe just circulate it around some of the members. Um, and Howard was very graciously allowed us to do that, so that's great. Before I introduce the speaker, anybody got any little bits of astronomical news to relate, or things they've been up to, or whatever, in the past wee while? Or are we just keen for the talk?
Deafening silence. We have the same problem.
I mean, just last week, I just stood outside the house and thought, "Oh, that's nice." So I didn't do an awful lot of very serious stuff. So I think it was just nice to see a good sky last week, wasn't it? Yeah. Okay. Well,
the exciting thing was I got a new astronomy camera. So I've got a mono camera now, and I can use the narrowband filters with it. So it's I'm getting quite excited about that. I mean, obviously, it's probably the timing's bad because it's going to mainly galaxies now for the next few months. But I'm hoping to produce some quite spectacular pictures with it as I get more proficient.
You should be able to do some proper astrometry with that then, so if it's not got that daft prism thing they put on the colour ones.
Yeah, that's it. You can actually use it for scientific purposes, couldn't you?
It's a real camera.
So, we've actually finished building our observatory in Moffat.
Good.
Mark. I've got a 16-inch Meade in place. So we're all set to open it up. But every time we set an opening date, COVID and lockdown hits us. So we've been opening it up for 2 years now. But we reckon maybe this year we might be lucky to get the thing.
Probably
look forward to seeing your colleague. Yes. Well, the red lights will guide us.
Oh, yeah. Well, they're fully illuminated with red, that's right.
Yes.
Was that 16 or 60 inches, did you say?
A 16, I'm afraid.
I thought it was going to be, we'll be all up there if it was 60.
Oh, yeah. Anyway, you're going to be very welcome to come over. We look forward to showing it to you.
Yeah,
oh, good.
We need to have we may actually be able to have a club outing at some point. Guys, come over and see that.
Yeah,
that would be great.
Yeah.
Very good. That's great. That's great news. Yeah. Okay. Any other wee bits, or we'll just move on to our talk? Yeah. Okay. I'll introduce our speaker then. Although you've now met him, we had a good chat. He's a lovely, approachable guy. So our speaker is Howard Parkin, and he's from the Isle of Man Astronomy Club. I was just trying to figure out if that's our second or third closest astronomical society. Because I looked at the distance; it's not that far away if you can fly there, and it's nearer than Wigton. So. So I'll really look at that, but I think it is one of our neighbouring societies, so we should probably do a bit more with them. And Zoom lets us do that, so that's really good. Howard's going to talk to us. His talk is called Ad Astra, and it's about space probes that have finally gone out of the solar system and are proper starships. They're on their way across the void, so we'll get. It sounds quite exciting. So that's one of the reasons why. Stephen is really disappointed he's not here at the moment, so let's hope that this thing is actually going to record all right today, and we can let him share with that later. But we can always report back and say you missed a wonderful talk anyway. So I'll pass you over to Howard, who's going to be able to share screens and things. If you've got any questions during the talk, could you maybe just type them into the chat box, because I'm going to mute everybody while the talk's on, and at the end we'll have a question session, and we can pick out some of the ones that, if you've forgotten your questions, they'll be in the chat box, or you can just bring them in at the end. So I'll just mute everybody, and I'll pass you over to Howard. So there we go. So let's just do that, and so I'll stop talking now because I'm going to mute myself, and then Howard will mute himself and take over. Here we go.
There we go. Can you all hear me? Just wave your hands if you can hear me. Excellent. Right. So, yes, thank you very much for the invitation. I'm sorry, Stephen, who actually got in touch with me and invited me to give this talk, isn't here. Hopefully, as you say, the recording will work. This is actually a talk I actually delivered. I've only done it about 3 times now. This is one of my newest lectures I do. And I actually delivered it to the Isle of Man Astronomical Society in February, which was it February or January? I can't remember now. I think it was February. We didn't have January. And so apologies to my fellow Astronomical Society members. You're going to hear it again. But it is quite exciting because, as you say, it's about the story of the 3 different categories of spacecraft that have actually left or are leaving our solar system. So if you just give me a second to share the screen, I will do that. And with a bit of luck, you should now have on your screen Ad Astra. And the let me just change my other screen to give me a gallery view. That's what I want. I don't want the big screen on that one. Just excuse me a second. I can't do that. Never mind. No, I can't do it. No, never mind. It didn't work. But I won't bother now. I can't see everybody. I can see you, Mark, and obviously a couple of others. But don't worry, because we'll have a look at the whole thing as we go through a bit later on. Just bear with me one more last second, see if I can do that. No. Side-by-side gallery. No. Exit full screen. No. No, it's not helping. Oh, well, that was a good idea, but didn't work.
Yeah, I can't give you any more powers there, Howard. That's basically all I've got on this account. So
I've got both screens are showing exactly the same as you're seeing. So anyway, don't worry. Okay, right. Well, this subject, as I say, Ad Astra, to the stars. And as one of the society members is mentioned to me when I gave it a few weeks ago, of course, this is part of the Royal Air Force logo. To the stars. I forgot what the next bit is now, something to do with difficulty with perseverance or something. But it's the translation of the word Ad Astra is to the stars. And when I was doing this lecture about a year ago, I first devised it. I thought, what can I call it? Long distance voyages or journeys to the stars? I thought, no, Ad Astra to the stars is suitable. And it is literally about 5 fantastic spacecraft that have now, due to the ingenuity of men and women, have actually left our shores forever and are sailing off into the cosmos. I like your comment a moment ago, Mark, about being starships. I've not thought of that before, but yes, they are indeed starships. They're heading out to the stars. So basically, why is that not working? Here we go. So here we are. Here we've got the 3 different types of spacecraft. We've got the Pioneer series of spacecraft. We've got the Voyager spacecraft, and we've also got New Horizons. New Horizons and Voyager are still working. They're still transmitting and sending signals back to Earth, albeit it's a long way away. And the Voyager spacecraft in particular are slowly losing their powers. The 2 Pioneer spacecraft, 10 and 11, packed up many years ago. But incredible ingenuity when you consider the ability we've got to send these out into space. And it all started way back in 1960. The NASA pioneers literally decided they wanted to build a type of spacecraft that would go out beyond Earth orbit. And they came up with the program called Pioneer. And there's actually 2 separate Pioneer programs. The first one was from 1958 to 1960. And these were, as you can see on the right-hand side of my table there, if it's in red, it failed. If it's in green, it was a success. So you can see straight away, going right back to 1958, right through till March 59, they had 4 successive failures. They then had the success of Pioneer 4 and a success of Pioneer 5. And the name Pioneer was originally given to the spacecraft because the US Army had launched their spacecraft and called it Explorer. Well, the Air Force wanted to show that their spacecraft were true pioneers. And that's where the name came from, which I found rather incredible. So they set off building them. And what I always love about astronomy is yes, we astronomers always have these wonderful ideas of looking up in the heavens and building telescopes and spacecraft and all the rest. It's the engineers that do the work. And the scientists, the Wernher von Brauns, if you like, come up with these ideas. Well, if we did this, so-and-so, okay, let me build it for you. And build it they did. And some amazing successes, but also some quite fails, some amazing failures as well. There's meant to be a film playing there. This is the Atlas Able launch on the 15th of December, 1960. It should play.
Pioneer Z was intended to be a lunar orbiter probe, but the mission failed shortly after launch. The spacecraft was launched on Atlas Vehicle 91D, coupled to Thor Able upper stages including an Able solid propellant third stage, on December 15, 1960. At T plus 73 seconds, the Atlas experienced total breakup and loss of telemetry. The upper stages continued transmitting data until impact with the ocean.
How ironic that it exploded at 73 seconds, because we all know of another mission that exploded at 73 seconds, some many years later. So that was one of the first attempts to launch a Pioneer probe, but eventually they had success with Pioneer 4.
A 4-stage Juno rocket stands at Cape Canaveral, the countdown for launching a race against the clock toward the last moment when it can hurl its payload across the moon's orbit and into outer space. Less than a day earlier, a previous attempt was scrubbed. Now, every electrical circuit rechecked and the fueling completed, the 60-ton Juno is ready for firing. Launching is slightly flawed, 95 miles an hour short of the planned peak velocity of 24,985 and its trajectory 2 degrees off. But the speed is ample to escape the bonds of Earth's gravity. The trajectory close enough to send the payload Pioneer 4th within 38,000 miles of the moon, 250,000 miles away. After a year of experiment and effort, 4 prior failures, the United States sends its first rocket payload into interplanetary space.
Don't you just love the music on those videos? Eventually, as I said at the bottom there was success. And a total of 19 Pioneer spacecraft were eventually launched between 58 and 78. 9 went to the moon. And I actually can't read my own text here because, unfortunately, the picture's in the way. Hang on, if I just do that, that's better. I can read it now. So a total of 9 missions went to the moon and were successful. But Pioneers 10 and 11, in the second series of spacecraft, the 2 Pioneers 10 and 11, they really were probably one of NASA's greatest success stories. The 2 spacecraft were built, as you can see here. And why am I not changing screen? Here we go. This is some of the experiments on board. You'll notice at the bottom there, above the title, radioisotopic thermoelectric generator. Even then, the environmentalists were up in arms about launching a nuclear isotope into outer space, because if the launch failed, there could be problems. Of course, we've now done that successfully with the Voyagers and indeed, I think, with New Horizons. But at the time, there was all sorts of public outrage almost at the fact that they were doing this. But the success of them both far outweighed, I believe, the risk that they took on it. Both spacecraft were built. Here you see a picture of the Pioneer 10 spacecraft to scale. Well, this isn't to scale, this is the actual spacecraft. You can see down the bottom right there. If I wave my my pointer there, you can see these people here. Literally, this is the size of the people. This is the size of the spacecraft with a huge dish, which was going to send the signals back to the Earth. And this is just another one here. This is Pioneer 11, I think. It might be 10, I'm not sure if it's 10 or 11, this one. But again, to scale, you can see somebody standing there. So they really were massive spacecraft. And of course, to get them into orbit, they had to be folded up and put in the payload bay. And that, of course, causes its own problems, as it did with Galileo spacecraft to Jupiter some years later. But these 2 spacecraft were almost flawless. They worked extremely well. And the plan was to send both spacecraft on the same mission. The spacecraft was to launch them a year apart. And the idea was that the second one would be a backup in case the first one failed. This was often the case with NASA. And even now they tend to build spacecraft in duplicate, but they don't necessarily launch the second one. But the 2 Pioneer spacecraft were to be launched in 72 and 73, and both spacecraft were going to Jupiter. That Saturn was not even in the equation at that stage. You'd get 2 flybys of Jupiter, and obviously the results of that, flying through the asteroid belt, that was something that was not been tried before. There was all sorts of concerns about the ability to do that without impacts on the spacecraft and knocking them off course and in fact destroying them. But the plan was to send both, as I say, one a backup to the other in 72/73. And because we were sending these spacecraft out, hopefully beyond our solar system, they decided they would put something on the spacecraft to advise that we existed as a human species on the planet. And here we go. This is the plaque that was placed on Pioneer. And this plaque was to be very highly debated. Quite a few scientific things on it. The hyperfine transition of hydrogen, a silhouette of the spacecraft, roughly to scale, to the humans. Then we've got the man and the woman there, I always think, what would the aliens think of us because we can't afford clothes? Either it's very warm in the Earth or we're a bit primitive. Oops, what happened then? I don't know what happened then. I think we just stopped sharing, didn't I? I pressed the wrong button. There we go. Here we go. So the man and the woman, obviously somewhat controversial. We also have the binary equivalent of decimal 8. Why 8? I've never known. You can make out these little map of the solar system here. You can see the large sun, Mercury, Venus, Earth, Mars, Jupiter, and then out beyond Jupiter, out into the cosmos, the trajectory of the spacecraft. And of course, this is quite a well-known drawing to anyone into cosmology. This is a drawing showing the position of the sun relative to 14 pulsars and the center of our galaxy. It's been used quite a lot in scientific books and magazines, and indeed was also used on Voyager. But eventually, they built the spacecraft, and Pioneer 10 was successfully launched on March the 2nd in 1972.
The second day of March, 1972, Pioneer 10 waits for launch atop a new three-stage version of the Atlas Centaur rocket.
Not the music.
13 months later, a sister spacecraft, Pioneer 11, left the pad on its long and chancy voyage to Jupiter and Saturn. It's not easy to break out of the solar system. It requires enough speed to defeat the sun's gravity as well as Earth's gravity. Pioneer streaks away faster than any previous spacecraft, gulping distance at 1 million miles a day, passing the moon in just 11 hours. Still, Jupiter is nearly 2 years away.
And you spot the deliberate mistake there. They actually told us that at the time of the launch, they were going to send Pioneer 11 to Saturn. That was not the case. This was the plan. Spacecraft launched from the Earth on the blue orbit there. The purple is the spacecraft, and it would intercept Jupiter on the 3rd of December 1973, and then its trajectory would be bent and it would be sent out into the outer solar system. And that's exactly what happened. However, it flew past Jupiter. It showed us that it could get through the asteroid belt successfully, and it took over 500 pictures, and the closest approach was on December the 4th, when it was about 82,000 miles away. That was an amazing success, and of course, Pioneer 11 was also on the way. The slingshot trajectory, though, this idea of using the gravity of something else to affect a trajectory, was something that had been discovered by Bepi Colombo, an Italian NASA Italian scientist, who calculated that the Mariner probe on its way to Venus could go on to Mercury if they deflected it using the gravity of Venus to send it into the inner solar system. If it was successful, and on paper it would revolutionize the ability to send spacecraft into outer space, into the outer solar system. Just a little bit of basics, of course, that if you carry a large engine and fuel on a spacecraft, then that takes up the scientific payload that you could have taken. So the idea of getting a spacecraft into somewhere else or out into somewhere else without having to fire a huge rocket engine to slow it down or speed it up, whatever you want to do with it, was always the biggest problem. And for many years, that's exactly what they did with the Mars spacecraft, for instance. Nowadays, we use aerobraking, and the Perseverance and Curiosity, of course, went straight in and didn't bother with it, carrying engines. You use the natural resources, if you like, of the planets to act as an engineering assist for you. So that enabled us to do something entirely different. And the idea that Bepi Colombo came up with, that you could send a spacecraft to Mercury using the Venus gravity well to send it there, was a major idea. And it did work extremely successfully. And because it worked so well, following the success of Pioneer 10 at Jupiter in December 1973, it was realized that they could actually change the trajectory of Pioneer 11 slightly. A slightly closer approach to Jupiter meant it would get a gravitational slingshot from Jupiter and literally sling it out across the top of the solar system practically to Saturn on the other side of the sun. Incredible idea. And because Mariner 10 was so successful, they agreed to do this. The primary mission of Pioneer 10 and 11 was to go to Jupiter. 10 had successfully done that and taken over 500 pictures. So they're not sacrificing 11, but what they're saying is if we just change the trajectory slightly to get this gravitational assist off Jupiter, it would go on to Saturn. Well, in April 74, just about 6 months after launch, they took this decision to retarget it to a certain location near Jupiter to give it a slingshot in December 74 to reach Saturn in 1979, some 5 years later. This is the revised trajectory, similar to the Pioneer 10, but now the spacecraft is being literally slung out across the solar system. The ticks underneath there show the height above the solar system to intercept at Saturn in 1979. Like, it has been likened to someone hitting a golf ball across the Atlantic and hitting a hole in one with the ball landing in the Gulf tee at Troon or somewhere all those miles and miles away distant. That was the plan. A little bit risky if you think about it, because they had never done it before. They didn't know it would work. They worked it out with Mariner 10, but this is a lot further away and they didn't want to lose the spacecraft. There wasn't 3 of them. I'm just letting it run while I'm talking about it. It would have been good if there'd been 3 of them, but that's what they did. And it was an outstanding success. As I say, like trying to hit a hole-in-one across the Atlantic Ocean. Pioneer 11 duly flew by Jupiter on the 3rd of December, 1974, a lot closer than Pioneer 10. It was 85,000, if you recall. Pioneer 11 was at 27,000 miles above the surface, which would give it the necessary slingshot to get it to Saturn. And this was one of the pictures taken on the 1st of September in 1979 from a distance of about 8,000 miles. We compare these now to Voyager and Cassini pictures. They're very, I won't say poor, but at the time, there was huge excitement. I can just about remember this mission. It really was an amazing success story. And NASA were understandably proud and delighted that they had succeeded in doing not just 2 spacecraft to Jupiter, but indeed to send 1 on their way to Saturn. There was a slight problem because when Pioneer got to where it was going to go, it was accelerating slightly less than had originally been anticipated. So when it was sort of 3 billion, 20 astronomical units from the Earth, it was actually not speeding up as fast as than intended. So they came up with the Pioneer anomaly. And if anyone would like to work this one out, please send me the answer. If you write it on a £20 note, I'm guaranteed to read it for you. But basically, they couldn't work out what the problem was. And eventually, after much debate, they realized that the I can't say the words, the generator on the end of the arm of the spacecraft was heating up the spacecraft, that it was ever so slightly affecting its velocity. Because it's in a vacuum, the spacecraft was heating up at one particular side of the spacecraft than the other. When they found Pioneer 10 had this problem and 11 had the exact same problem, they realized, or they thought it was something different, something slowing them down as they went into the interstellar medium or out to space. But they then realized that both spacecraft were actually oriented exactly the same. I think the generator is on the end of this arm here, or I'm not sure which one it is. It was on the other diagram. But obviously, if it's in the exact same spot, an exact same configuration of the spacecraft going out into the cosmos, then this would cause the problem. But for a while, they really thought there was something else out beyond the orbit of Saturn that caused spacecraft to slow, something completely unknown. In the end, it was exactly what we said. It was what they call thermal recoil. Now, in 1965, some years before Pioneer, a chap called Gary Flandro at JPL had realized that they could actually find a spacecraft could get all the way out to the outer planets, including Pluto, because the spacecraft were going to be aligned in a certain way. And the idea was they could, between 1976 and 1978, send a spacecraft to all 5 planets. And yes, Pluto is still a planet at this stage, remember? Pluto was a planet until 2006, I think it was. They're all lined up on the same side of the sun, and NASA put forward the suggestion that they could send a spacecraft to visit all 5 planets. It's a very rare alignment, only happens every 175 years. So literally only 10, 12 years beforehand, this chap had realized that we could use this and use the slingshot effect to get them there quite easily. Well, not easily, but certainly with the minimal use of fuel and a maximum payload available using the rockets we had available. So the Voyager missions were planned. Now, originally, the idea was to do what they called the Grand Tour and have a total of 4 spacecraft going out into the outer cosmos. But unfortunately, budgetary constraints, look at the date, 1973. This was just after the Apollo program had finished. And you all know how that ended. Sadly, the public interest waned considerably and the money was just not available. So eventually, poor NASA had to reject the proposal. They didn't get the funding for it and the Grand Tour was never done. However, there was a much watered down version using a Mariner type spacecraft called the Jupiter-Saturn 77 or MJS-77, where 2 spacecraft would visit Jupiter and Saturn. And NASA did something they shouldn't have done. NASA actually broke all their own rules. When they built these 2 spacecraft, they built Voyager 1 to go to Jupiter and Saturn, but they increased the specs on Voyager 2 to possibly be able to send it on to Uranus and Neptune if the funding could be made available at a later date. They did this in total secrecy. At the time, if it had been realized, there probably would have been all sorts of problems, but you can all guess what happened. Eventually, they did launch Voyager 1 and 2 to Uranus and Neptune as well. And they'd realized now that the engineering they did on the Mariner class of spacecraft, which had been very successful to Venus, Mercury, and of course to Mars, the Mariner class spacecraft was being completely refurbished, completely changed. So they decided to rename these spacecraft Voyager 1 and Voyager 2. And Star Trek were to pinch the name Voyager off them some years later. But Voyager 1 and Voyager 2 were both scheduled as Pioneer 10 and 11. They were both scheduled to visit slightly different. They were both scheduled to go to Saturn, not just to Jupiter, but that Uranus and Neptune were not on the drawing board at that stage. And this is the trajectory. This was the plan. Voyager 1 would go to Jupiter in somewhat similar way that Pioneer 10 did, but then slight incline, reaching Saturn some many years later. And that was the plan for Voyager 1. On the spacecraft, they decided to put a plaque. Sorry, not a plaque. They had the plaque on Pioneer. They decided to put a record. How is this for technology? Nowadays, if you've got a long playing record, could you play it at home? How many people here have got LP decks and needles? Well, Mark's got one, never mind. I haven't. I did have one, but I can't get it to convert to MP3, so don't bother. So this long playing record was placed on Voyager, and this would tell us about our existence on the planet. And you can see on this here, you've got the dimensions of the sun relative to the pulsars, and you've got all sorts of things on here. That's how you're going to play the record. So if it's like IKEA, if some alien finds it, it'd be like getting an IKEA package, and you can open it up and work out how to put it together. These waveforms tell us about what's on the disk. We've got image stabilizers. We've got all sorts of things on it. And the pulsar map we had before. But the difference with the record was, of course, they could play sound and have vision on it.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
And at this point, we should play Chuck Berry's song. Unfortunately, last time we did that, it got censored by FaceTime because of the copyright. Interesting point on that. NASA actually got the copyright to play Johnny B. Good on their spacecraft. They actually released the copyright to them. The Beatles were asked and refused to give their copyright. So Chuck Berry's music lives on, as Carl Sagan tells us here. So I could argue that I'm playing it because the copyright's with NASA, but FaceTime or YouTube don't accept that, and they banned it from being played. And so unfortunately, that's why I've taken it out. But a marvelous letter here. I mean, how's this? Rock music, we all love Chuck Berry, and here you've got one of the godfathers or one of the premier scientists of the time, Carl Sagan, telling Chuck Berry that his spacecraft will live literally for 1 billion years or more. Just incredible story. But that's what they put on board the 2 Voyager spacecraft. They both set off only about a month apart, or a few days apart actually. Come on.
2, 1. We have ignition and we have liftoff. We have liftoff of the Titan Centaur, carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
So there they both go. Now you'll notice that Voyager 1 went second. Voyager 2 went first. Voyager 1 was going to Jupiter and Saturn, was going slightly faster, and it did in fact reach Jupiter first, but Voyager 2 went first. After the launch in October, the idea of sending both spacecraft to Uranus and Neptune was renewed. And famous name from the JPL laboratories, Ed Stone, actually put forward the suggestion that Voyager 2 could actually be sent on to Uranus and Neptune should they both be successful at Jupiter and at Saturn. So they had to meet the primary objectives at Saturn. And although it had been uncertain at the time, they had over-designed Voyager 2 with the capability to reach Uranus and Neptune. If they hadn't, they don't think it would have made it. But they did. They did what they weren't meant to do. They actually spent more money on Voyager 2 than they should have done. They got permission to do it. And eventually, the Voyager 2 mission was as follows: Jupiter to Saturn, and then to Uranus, and then on to Neptune. They could have sent one of them onto Pluto, but to do that, they would have sacrificed the ability to have investigated Titan around Saturn. Voyager 1 originally was scheduled to go to Jupiter, Saturn, and Pluto, but they didn't do that because they wanted to make sure they could get to Titan, because they knew from telescopic observations that Titan had this atmosphere, and they wanted to investigate it further. So if you like, Pluto was sacrificed for a closer look at the moon of Titan around Saturn. Voyager 1, when it passed Jupiter, sent us back some fantastic pictures. I mean, we thought the pictures from Pioneer were good, but the Voyager pictures are still impressive even today. It imaged Jupiter right through from January through till April. It approached at a height of 217,000 miles. And Voyager 2 was to follow not long later, from April to August. So basically, we got a chance to look at Jupiter right through from January right through till August. Both spacecraft then went on to Saturn. Sorry, before I go on to Saturn, these are just some of the amazing pictures. I mean, we've had pictures since then from Galileo and Juno and things like that, but these Voyager pictures really are just a class amazing. When you consider the great spot of Jupiter there, 89,000 miles in diameter. Incidentally, it's reported over the last 20 or 30 years that the spot is slowly getting smaller. It keeps coming and going, but it is, if anything, it's getting smaller. And there's a speculation that possibly the spot may ultimately disappear. But we'll wait and see about that one. They also found out that Jupiter's got rings, very, very thin ring system, very small compared to those of Saturn and indeed Uranus and Neptune, but all 4 of the outer planets are in fact ringed. One of the amazing stories, I'm sure you've all heard this story before, about the eruptions, the volcanic eruptions on the moon Io, discovered by a postgraduate student who spotted what she thought was a photographic flaw, and then realized that this flaw was actually the eruption of the volcano on Io. And this was taken from Voyager 1 and discovered in 1979 in March during its flyby. Then, of course, both spacecraft went on to Saturn, and I just love this composite picture here. Voyager 1 arrived in November 1980, 77,000 miles approach, and of course it went on to look at Saturn's moon Titan. Titan, of course, with the atmosphere, which was ultimately lead to the Huygens probe, which was deployed from Cassini some many years later. Voyager 2 also approached, and was a height of about 26,000. Sorry, that's the date, 26th of August 1981. I thought I'd missed a comma out there. And as I say, this picture, a wonderful composite picture of these moons and the family of the moon Saturn. Incidentally, I've just been looking up which moon, quick question for everybody, which moon in the solar system, sorry, which planet in the solar system has got the greatest moons? The answer is Saturn. It's just overtaken Jupiter again. Jupiter's got 79, Saturn's got 82. So it chops and changes literally every 6 months or so as they discover more and more different moons around these two big giants. The ring system, of course, absolutely incredible. I'm sure there's not a person watching this program tonight who hasn't seen the rings of Saturn for themselves and thought, wow, they're just amazing. As we always say, if you show a child the rings of Saturn through a telescope, that's it. They're hooked on astronomy forevermore. Mimas, of course, this was a wonderful picture of Mimas, and often called the Death Star because they reckon this looks like the one that was in Star Wars. And there was some speculation that the two were linked in some way, that George Lucas, never sure which one came first, but there's all sorts of speculation that the inspiration for some of the Star Wars stuff came from the Voyager mission. Enceladus, of course, we now know is an ice moon, completely ice covered, and we believe there could be liquid oceans underneath the surface, and maybe, just maybe, the ability for life, primitive amoeba or something, to exist below the icy surface of Enceladus. And in fact, when you consider that, and you consider Europa, and you consider Mars, and you consider the Earth, there are 4 potential places that life may have evolved in the solar system, which, when we consider there's only one place we've got life at the moment, this is why the scientific quest for finding life elsewhere in the universe is so important. Titan, with its atmosphere from Voyager here, Voyager 1, of course, Voyager 2 didn't go anywhere near it. This sort of photograph inspired them to get the funding together to build the Cassini spacecraft and send Cassini back to Saturn, and also to deploy the Huygens lander, which is another story which we won't touch on today. But that was an amazing discovery by the European Space Agency to get that spacecraft onto the surface of the moon Titan. Voyager 2, of course, then flew on to the planet Uranus. It got there in 1986. And unfortunately, a few days later, we had the Challenger disaster. So the great success of Voyager at Uranus, the first time we'd seen this planet from our vantage point in the Earth, was muted somewhat by the terrible problems that befell Challenger on launch. But whilst Uranus itself was quite boring, for want of a better word, a very featureless disk, the moon Mimas, Miranda. Miranda was truly spectacular. It looks as if it's been broken apart and then reformed together. Uranus rolls on its side, as I'm sure most of us know. It's got an inclination of 98 degrees to the axial tilt, 98-degree axial tilt, and it rolls around the solar system. And obviously there are temperature differences at the polar regions opposed to the equatorial regions, which you'd expect. But apart from that sort of image, there wasn't much interest photographically on Uranus. There was some upper level clouds taken from 8 million miles away. But Miranda, I'll just go back a fraction if I can, because I wasn't meant to press that button so quick. And if I go back, no, well, let me go back. Yes, it will. Let me, if I use that way instead. There we go. This is Miranda, and it just looks completely as if it was broken apart by a huge impact. Maybe something similar that happened to Mimas, but Mimas managed to maintain its integrity. But it looks like Miranda was completely blown apart and then reformed. And these amazing features on the surface, totally unexpected, and was something that was an amazing discovery photographically. And to date, we haven't sent anything else back out to Uranus, but I know there have been plans which have not quite made it yet. And I think it's only a matter of time before we send some more spacecraft out to the outer solar system. Voyager 2 then went on to Neptune. It went on to Neptune, not quite as featureless as the planet Uranus, closest approach of just about 3,000 miles away. They had a dilemma at Neptune. If they went too near Neptune, they wouldn't get to Triton. And if they went too close to Triton, they couldn't get as close to Neptune. And there was a dilemma that the ring system might have damaged the spacecraft. In the end, the Triton dilemma, as it was known at the time, came to nothing. And the spacecraft sailed through the system quite successfully. And of course, became the longest place that we'd ever seen, the furthest place we'd ever seen with the spacecraft for many years to come. The Voyager 2 also discovered the Neptunian ring system and a load more moons. This is the great dark spot on Voyager, which we now know has disappeared. The Hubble Space Telescope images have shown that the great dark spot, which we originally thought was similar to Jupiter's red spot, had in fact disappeared. We now believe it's literally a window in the upper atmosphere, and you're looking down into a further into the depths of the clouds of the planet Neptune. The ring system, photographed here with the planet occulted in the middle there, you can see the ring system, not quite as good as, well, certainly nowhere near as good as Saturn's, not quite as dramatic as Uranus's, but certainly better than those around Jupiter. And Triton, the moon of Neptune, has a weird landscape as well, and there's speculation that there's maybe ice or maybe processes going on Triton that warrant further inspection. But at the moment, as I say, there's no funding for a mission to the outer planets at present. The final picture Voyager took, either of the Voyagers took, of the outer planets was this one. The smaller disk in the front there, in the foreground at the bottom, is actually Neptune, and Triton is in the foreground. And that was meant to be the last picture that was taken by the Voyager 2 spacecraft. However, scientists on the Earth, before they switched the cameras off, were pleaded with NASA, would you take a picture of the outer solar system? Of the solar system. And these images here are most of the planets in our solar system. On Valentine's Day 1990, from about 4 billion miles away, these were the last pictures taken by Voyager. You've got, here we go. Something's happened there. My screen just got smaller. My screen just went to smaller. Oh, that's me talking. Get off. I don't know what I've done there. Sorry, I'm just stopping that, starting it again. I don't know what I managed to press there. It was actually commentating on myself. Slideshow. No, sorry, apologies. I've played it from the start. I've got to stop it again now. Sorry. The joys of oh, I don't want it from the start, do I? Well, just amuse yourselves a minute. This is where you say to the audience, just amuse yourselves while we sort it out. Where are we? Where have we gone? There we are. We'll go to that one. Slideshow from current slide. There we go. So we're back to Triton and to Neptune. And this is the picture taken of the solar system from Voyager 1 before the cameras were turned off for the last time. And when it looked back, it was able to image 6 of our planets. There we've got the planet Venus, the planet Earth, the planet Jupiter, Saturn, Uranus, and Neptune. Mars and Mercury were not able to be photographed at this time. Just an amazing image, basically showing just how small and insignificant we are in the greater scheme of the cosmos. And Voyager's last image of the Earth, of course. This is the actual image from Voyager. They've cleaned that up not long ago to celebrate the however many years it's been since Voyager. And this famous pale blue dot, which was so aptly described by Carl Sagan all those years ago.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam.
Oh, I must have played that dozens of times, but it's just absolutely incredible, and such an amazing scientist. I always think Carl Sagan was probably the American equivalent of our Patrick Moore, and they just don't make people like that anymore, do they? Here we go, carrying on. I hope. Why are we not moving on? I don't know why we're not moving on. Why aren't we moving on?
From this,
I've heard you. Thanks, Carl. Here we go. And in 2017, Voyager 1, they actually had a problem. They realized that one of the thrusters was not working quite as well as it should have done. So they actually fired up one of the thrusters on April the 23rd, 2017. They actually fired one of the thrusters to see if it would still work, so it could still maneuver the spacecraft for commands and everything else. And they were able to get it working after all those years. How many of you have got a car that's 40 years old that works? And not just a car that works, but you haven't serviced it. You haven't done a thing to it for 40 years. Incredible. Okay, we've got no decay in space and all the rest, but it was incredible that these hydrazine thrusters would still work after all that time. Then in January 2020, only last year, they had another problem with Voyager, and an automatic protection routine was activated, and they were able to, again, they switched it off, they switched it back on again, and they got the spacecraft working again at 11.5 billion miles away. It took 17 hours to get the signal to the spacecraft, of course, another 17 hours to find out whether the fix had been successful. Again, it just proves how successful they can be. And a few days later, announced that it had been successful. And the remaining instrumentation on board Voyager 2 is still functioning. And as of the last time I looked, which was only this morning, I just, before I did this lecture, I wanted to see if there'd been any news about Voyager recently, and there hasn't been. Both spacecraft are still functioning, although obviously they are slowly having to turn off different instruments. What they do basically is they turn them off one at a time. When they've got not enough energy, not enough electrical power to operate the machine, they'll slowly turn them off one at a time. And they're down to 5 now on Voyager 2. I think they're down to 3 on Voyager 1, but don't quote me on that one. But still, they go on. February 2020, they switched them off for an upgrade deliberately. 9 months later, they started working. Then they had another problem in the density of space in the outer solar system. And then they worked out eventually that there's a large-scale feature called the VLISM, Very Local Interstellar Medium. Somewhat similar to the Pioneer problem, but this is externally caused, nothing to do with the spacecraft, but not totally unexpected, and has been more or less explained, although we won't go into that tonight. But that leaves us with the final member of our trip, and that is, of course, the New Horizons spacecraft, which was launched in 2006 to Pluto, the planet Pluto, because Pluto was still a planet at that time. Should be a video there.
T-minus 15 seconds.
ready? Roger.
15 seconds. 11, 10, 9.
Quality of videos has improved since the Pioneer 4 days.
5, 4, 3, 2. We have liftoff of NASA's New Horizons spacecraft.
I'll just play this for a moment. Hey, I wonder if this is the song that
may help us to understand better how our solar system.
I'm going to turn that off because I suspect, I hadn't realized that, I suspect that's the song that the copyright may have been infringed on. Not Chuck Berry. Anyway, we'll find out if it gets switched off. Mark, let me know, will you? If you find that it's removed, apologies. That song, incidentally, was written by Brian May of Queen fame. He made a song called New Horizons, and it's a great song, and it's obviously got all the flyby of Jupiter and everything else on it. So I'd completely forgotten to have that song on as well. So en route to Pluto, New Horizons went past Io. This is Io, and this is a time lapse now showing a few passes. You look very close, you see the planet twitching a bit. It's actually about 5 images all stitched together showing the eruption from Kashvas Tar volcano. Sounds like a character out of Star Wars, I think. But eventually, of course, New Horizons approached Pluto, 14th of July, 2015. And it, well, words fail me. There's the TV program at the moment I've just been watching, I think it was Horizon. And Pluto was thought to be a frozen ball, a leftover fragment from the origins of the solar system. But the conditions on Pluto are absolutely amazing. We've discovered there is actually geological activity taking place on Pluto. there's an eruption of water ice, which is fueled by ammonia and water ice mixed together, can cause volcanoes to erupt ice, and the surface is being renewed in comparatively recent times. And it really is a complete and unexpected treasure. And I think I mentioned a few moments ago about there's been no spacecraft to Uranus and to Neptune. I wouldn't mind betting there'll be another spacecraft going to Pluto in the next 10 years, at least on the drawing board, because Pluto just completely shocked everybody with its geological features. And we want to know so much more. As ever, when we send something out, when we ask a question, for every answer we get another 10 questions. And the Tombaugh region, named after the chap who discovered Pluto, I always feel sorry for Clyde Tombaugh. He discovered a planet only to lose it. And I know NASA still feels strongly about that, and so do I. Pluto should still be a planet. We know Columbus didn't discover America, but we haven't changed the history books to that, so why do they change it? You know the answer to that question. One of the theories is that the NASA scientists, not the NASA scientists, the International Astronomical Union, liked the idea that Uranus and Neptune were discovered by Europeans and didn't like the idea that American would be attributed to the 9th planet. So I don't know how true it is. But I'll also make you another prediction. There is thought to be another planet out there, probably about the size of Neptune. And we believe that is almost definitely out there. The mathematical theory says it's there. But when they finally discover it, I'll guarantee the name of the new planet, the 9th planet, if you like, or the 10th planet, if you want to be a purist, will be given the letter P. It will start with the letter P, because otherwise the mnemonics, which have been forgot about now, will all be forgotten forever. So my bet's on Persephone, which was one of the plans to call a 10th planet some years ago. So Pluto, here we've got the features of Pluto, tremendous winds on the surface of Pluto, and it really has been an amazing discovery.
Meet Ultima Thule. Just like with Pluto, we could not be happier. What you're seeing is the first contact binary ever explored by spacecraft.
I forgot to do the introduction to that one. Of course, the New Horizons spacecraft went on then to Ultima Thule, as it was called at the time. And this was another dramatic discovery, still quite some way away, but it was able to prove that these contact binary, this idea of two objects fusing together, which is the whole principle of basically how the cosmos works. If you like, objects fuse together, eventually there's so much mass that a star is born. And it's the same principle with planetary formation. And this Ultima Thule, as it was called at the time, was again totally unexpected. The Hubble Space Telescope was able to reveal that it was slightly anomalous in that there was a bulge on one side. But of course, we've now realized that this is actually two objects which are fused together. But there was a sting in the tail, because Ultima Thule had to be renamed, because they realized that Ultima Thule is the place where Nazis go. It's the Nazi equivalent of Valhalla. So when this was realized, they changed the name of Ultima Thule to Arrokoth, and now Ultima Thule is gone. The contact binary that he referred to there a second ago is now known as Arrokoth. Where are they all now? Well, this was a snapshot done a few weeks ago now. This shows you the statistics of where they all are, the distance from the sun. But one I like in particular is this line here, one-way light time. To get a signal to Pioneer 10 takes 17 hours, Pioneer 11, 14, Voyager 2, 17, Voyager 1, 21, and for the other one, 6.97. So New Horizons, of course, is still substantially nearer to us than all the rest. And an interesting little footnote, if you look at the magnitude of the sun as seen from any of these spacecraft would still be around -12. In other words, the sun would be as bright as the full moon. Even all that massive, massive distance away, the sun by far outweighs the brightness of any other object. Really incredible that these spacecraft are still there, well, 2 or 3 of them are still working, and they have been an amazing success and something that we as humans on the Earth should be very proud of. Where are they now? This is just a graphic to show roughly where they are compared to the solar system. The inclined yellow orbit there is that of Pluto, and you can see all the spacecraft pretty well going in different directions altogether. The New Horizons spacecraft will intercept another object in the not too distant future, MU-69, but all the other spacecraft, I've got no prospects of seeing anything or being anywhere near anything else. Pioneer 10, 11, as I say, have sadly gone to the great scrapyard in the sky, but are still moving. But Voyagers 1 and 2 will keep going for a little bit of time yet. And this is the extent of the size of our solar system. You'll see that the New Horizons spacecraft are still to cross what we call the heliosphere. There's some huge debate about where the solar system begins and ends, but we define it as the edge of when you go through the heliosphere, the influence of the sun, then those spacecraft are deemed to be in interstellar space. Voyager 1 finally exited the solar system on the 25th of August 2012. This was followed by Voyager 2 on the 5th of November 2018. Pioneer 10 they're going much slower, the Pioneers, of course, will exit in 2057, Pioneer 11 in 2027, and New Horizons in 2043. By then, I think New Horizons have still got quite some time to work, but the two Voyager spacecraft will probably no longer be working past about 2026, 2028 is the estimate, given the electrical supply they've got. But New Horizons, they hope, will still be transmitting for about another 20 years or so. Incredible, really, when you consider how far they've gone and the engineering that built them and the fact that we can still track them from on the Earth. And I'd like to finish with a quote from a famous author who you may have heard the words related by somebody else.
Second star to the right. And straight on till morning.
Famous words by Captain J.T. Kirk and, of course, J.M. Barrie. So, in conclusion, from our 5 Intrepid spacecraft, as we head out of the solar system, we've got the 2 Pioneer spacecraft launched way back in the 70s, the 2 Voyager spacecraft, which followed not long after, and of course New Horizons, which is comparatively newcomer to the region, but all 5 are amazing. And astronomy, as ever, compels the soul to look upwards and leads us from this world to another. Thank you all very much indeed for your kind attention. I'll just go back to that one and we'll unshare the screen. If I can do that. Why can't I unshare the screen? Come on. I can't unshare the screen. Stop share. There we go. So I hope you enjoyed that. I hope that made you think a bit about the ingenuity of mankind to do those sort of things. And I'd be more than happy to answer any questions.
Thanks very much, Howard. Does anybody have any questions they want to pass on to Howard at this point? Oh, yeah, James.
Yeah. Howard, you say that New Horizons and Voyager are still working. Are they sending any information back to Earth that's of any use or interesting?
Yeah, they're basically telling us information back from the. I'm just going to mute. Let me just mute my. That's okay. My other computer.
That was my fault.
They are still sending back details of what they can find in the interstellar medium, and they're sending back density and any observations. They're not using photographs as such, but the radio generators on board are still working. On New Horizons, I think pretty well everything is still working on it. The Voyager's less so, but that's forgot my name. I used it now. Not thermal recoil. The other one, the VLISM or something. That was a discovery that both the Voyagers, one discovered and the other backed it up as well. And whilst New Horizons hasn't got that far yet, they anticipate they'll find the same readings from New Horizons. So they are still sending back meaningful data.
Yeah.
As last year, they switched off the transmitter at the Deep Space Network while they refurbished it. And of course, when they switched it all back on again, there was Voyager 2 still. So, just an incredible piece of engineering. Hopefully there's some more discoveries to come.
Yeah, good.
Thank you. Anyone else?
Yeah, I've got a question. What's your opinion on sending out the location of the sun on these things? Do you think that would be a different opinion now, and whether we still
quite possibly? I mean, it's an interesting question because, of course, we all want to communicate with aliens. We all have this ambition to find out we're not alone in the cosmos. But I just think, are the public ready for something like that? And there's always don't get into conspiracy theories and all that sort of stuff. But we have sent out a roadmap. Here we are. Come and get us. I wouldn't like to comment any further than that, really. Thank you, James, for that comment.
I suspect we may not be here when they come back. So,
I was very fortunate a few years ago. I managed to get to Arecibo in Puerto Rico. And of course, you all saw the disaster that befell that place in December. And of course, one of the big things Arecibo was famed for was communicating or sending out signals to the stars to try and detect extraterrestrial life. And I think it's just a great shame that that telescope is now basically gone, and there's no immediate plans to refurbish it or do anything with it, but we'll wait and see. Anybody else? You're all very...
anything else planned to go out there?
There is a probe, I understand, on the drawing board to go out to Uranus and possibly Neptune. That's very much an embryo of an idea. NASA now have got this habit. They actually come up, and so do the Europeans, to be fair. They ask scientists to come up with a scheme or a project, and then they'll select one of the projects. And of course, what happens is, okay, I'm going to send a spacecraft to Mercury. You're going to send a spacecraft to Uranus. I make a more convincing case than you, so my probe to Mercury gets given the go-ahead. It doesn't mean that the Uranus one doesn't go ahead. It means that it obviously falls back another 5 or 10 years. And of course, the whole idea of these missions is to build them and get the scientists to literally take them from birth out to the planet. I mean, New Horizons is a classical example of that. Incidentally, an unasked question that I've been asked before is, did they not send anything on New Horizons, like a plaque or a record? And no, they didn't. When they built New Horizons, they realized they didn't want to get involved in a public debate about what we should have on board. So the only thing they sent some stamps and some coins. All the scientists signed a little disc or something, but there's no fundamental message on New Horizons that there is, of course, on the 2 Voyagers and, of course, on Pioneer.
So is Britain involved at all in any of the next planned missions at all?
Not that I'm aware of. I think some of the smaller missions. I know we've got a moon mission planned, which there's the one that looks like a spider that's going to be crawling around the moon by the end of the year, hopefully. But there's a lot of science done in the UK, of course. But it's depressing that of all the nations in the world that have a launch capability, there's only one that had a launch capability and then threw it away, and that's Britain. Although I see Scotland is going to be launching satellites up in the islands sometime soon next year. Is that right?
Yeah, we're going to launch some of recycled plastic as a fuel. Oh, green rockets.
Green rockets, I love it. Anybody got anything else? If not, I would like to thank you all very much indeed for inviting me to talk to you tonight. I hope you enjoyed that. Mm-hmm. It's quite a historical research job, really, when you consider those 5 spacecraft. And I just was asked some time ago about it, and I thought, well, it'd be great to talk about the Voyager spacecraft. But well, you can't talk about Voyager without talking about Pioneer, without talking about New Horizons. So fascinating stuff, and hopefully there'll be some more missions in the not too distant future. But I think at the moment the concentration seems to be on the moon and maybe to Mars. We'll wait and see.
Makes a nicely themed talk when you have all the distant probes together. It's quite a story, that. So thanks very much, Howard, for taking the time to give us a talk. And maybe we could all see what's got a weird noise happens if we try to give our vote of thanks. So I'd like to thank Howard in the usual way and see what happens. Thank you very much.
Indeed, it was a pleasure, and I hope our paths may cross again via the virtual media, or who knows, maybe someone will get to the Isle of Man. Invitation to anybody to come along to the Isle of Man to one of our meetings if ever you get here. At the moment, we can't even leave, never mind get here. Well, our society meet on the first Thursday of every month. Who knows? Get in touch if you're thinking of coming to the island, and likewise with any of us from the Dumfries area.
Yeah, well, the Freestone Society, this is our last actual talk of our season. The next thing we'll have is an AGM, and hopefully lots of people will turn up to that. But see, we're hoping that come September we'll be launching up more of a hybrid meeting and actually have people in the room together. So we'll wait and see what happens. Yeah, it would be great to do a trip to the Isle of Man sometime. So wait and see whether that's possible. Yeah. Thanks again, Howard.
Right. And
Thanks very much. Thanks for the invite.
Thank you.
Thank you.
Thanks very much, Howard. Great stuff.
Thank you very much indeed. Thanks for inviting me.
Bye.
Good night.
Night.
Good night, all.
Cheers, Carl. It was fascinating watching everyone disappear.
It's great. Yeah, people move out very quickly from the room, don't they? There you go.
12 months ago, we never even heard of Zoom, had we?
Nope. Yeah.
There we go.
Great stuff. Right. Well, I'll bring this to a close, and thank you very much, Howard, for your time. I think Stephen's going to be in touch about your fee at some point, so we'll get that sorted out. But
I also recorded it, so if your recording doesn't work, let me know.
Oh, right, I'll let you know. Yeah.
I know when you switch it off, it will convert it to an MP3 file.
Yeah. I'll leave it to cook. Yeah.
Very heavy on memory.
Yes. I'll keep
it for a few days. So if you haven't got it, let me know, and I can always perhaps send it to you.
I'll be in touch about that. Thanks very much, Howard. Okay.
My pleasure. Good night, everybody.
Thank you. Bye, December.